this point, how do I know that angle 1 and angle 4 are equal?
They're the same color.
Because they are the same color. I like this. That's a good idea. Now, we could say that blue is equal to blue. All right? So if blue's equal to blue, what do you think about red?
Red is equal to red.
Yep, red is equal to red. How about red plus blue?
That equals purple.
Yep, it equals 180. We're not in art. Sorry. Right? And the idea is that I can do this with anything, but I'm choosing red and blue because they come in every single whiteboard color pack. There's really nothing special about these. Same with the numbers. There's really nothing special about them. It's going to be the relationships that we come up with that are special. Okay, so how about this? Okay, so angle 1 plus angle 2, that's equal to 180, right?
Yes, sir.
They're both on the same line. Okay, how about angle 2 and angle 4?
180.
They're equal to 180, right? It's just another line. So, okay, who had the symmetric property? Okay, great. Use the symmetric property to restate this thing. Okay, what is the symmetric property? So the symmetric property is if A equals B, then B equals A. So how do I use that? So if 2 plus 4 equals 180, then
4 plus 2.
not quite. We're switching the things on the other side of the equals.
180 equals.
There we go. So 180 is equal to angle 2 plus angle 4. Okay, so there we go. I like this. I'm going to get rid of this middle guy because I think it's clouding this up a little bit. Okay, who had the transitive property? All right. What did the transitive property state?
It says if A equals B, B equals C, then A equals C.
If A equals B and B equals C, then A equals C. So right now I have if 1 plus 2 equals 180 and 180 equals 2 plus 4, then what can I say? Okay, so like this, let's say that's my A, right? And this is my B. This again is a B, right? This is my C. You see that? So how do I rewrite this thing? There you go. 1 plus 2 equals angle 2 plus 4.
Wait, but how did you get? Hang on, okay.
Right? Yeah, if 1 plus 2 equals 180, right? This is like 10 dimes equals $1, and $1 equals 4 quarters, then 10 dimes equals 4 quarters. Right? So, now, this could be simpler, right? How would we simplify this? What do you notice about this equation? There's something. There's something on both sides, right? What is on both sides? 2, right? So I could subtract angle 2 from both sides, right? A positive angle 2, negative angle 2, those guys go to 0. Same with this. and I now just have angle 1 is equal to angle 4. Ta-da! So that's what we were trying to do before water didn't work, and basically Christmas break happened early. I mean, basically, the stars aligned and retaliated against this short break that the calendar committee gave us, and gave us an extra long break, right?
Wow.
Basically, that's how I see it. So, but that's why we didn't get to go over that proof. So I just quickly did it. Okay, so now let's talk. So that's why angle 1 equals angle 4 and why angle 2 equals angle 3. Okay? But that's only one set of intersecting lines. So let's take a look at if we want to do these two. Now, what do we call two lines that do not intersect?
Parallel.
Parallel. Exactly. And we're going to denote that with a little triangle on the lines, or a little arrow. Okay? So, now, what do the sum of the inside of a triangle add up to be?
180.
180, right? So let's pretend that maybe this isn't parallel at this point. If these guys aren't parallel, that means they intersect over here somewhere, right? Okay. So if they intersect over here, even if it's, a mile down the road, we know that these two angles, they can't add up to be bigger than what?
180.
180, right? Okay? If they intersect over here, then those two have to be smaller than 180 to get in there. Okay? What happens if they're bigger than 180?
They won't ever touch.
They won't ever touch. That's very true. But they'll
Yeah,
touch over here, won't
yeah.
they? Yeah. So we want this angle and this angle to be exactly 180. Okay? So what color does this angle need to be?
2. I mean red.
Yeah.
Oh, fuck, no.
Okay? And that gives our colors for the rest of the angles. Okay. Now this is a very commonly known situation. This is a whole unit in geometry, and it has a lot of vocab that goes with it. Okay, so I'm going to try to explain this vocab to you in the way that it's built. Okay? So this line is called the transversal. Can you guys think of another word that has that beginning trans with it?
Transition.
Transition. Yeah, what does transition mean?
Switch.
Yeah, to switch or to change over, right? Right? How about transcontinental? What does that mean?
Means two different continents.
Yeah, it goes across. That's actually transoceanal to a different continent.
Transatlantic or transpacific.
There you go. Transcontinental would be like New York to Los Angeles. Or there's railroads that are transcontinental, right?
Nope.
One of them goes right through town. That was a big deal when it was getting put in. There was a race to see who could do the first transcontinental railroads. Okay? Transportation. Change. So this is something that crosses over both of these. That's all it means. Okay? So, now, there's two types of paint, right? There's paint that you paint on the inside of your house and paint that you paint on the outside. What are those called? Interior and exterior, right? So everything inside these lines we call interior. And we call this stuff over here exterior. Okay, so I'll just go and make my table now. Okay? You can either be interior or exterior. Same side of the transversal or alternate. Okay? An alternate, like if you're waiting in line at the DMV and there's two lines and one register, one person from line A goes, then one person line B, then one person from line A, and then one person for line B. It's like a zipper, right? It fits together like this. It alternates. Okay? That's where that word comes from. So, if I'm interior and I'm on the same side, what angles are same side interiors? I guess what I'm getting at. 5 and 3, yeah. Okay, there's another pair. What are they? 4 and 6. So what can you tell me about same side interior? Do they equal each other? Do they add up to 180? And that's going to be the theme of this unit. They either equal each other or they add up to 180. All the problems are going to be solved with you either setting them up so that they're equal or that they add up to 180. That's really how all of these problems go. So, 5 and 3, do they add up to 180 or are they equal to each other?
5 and 3 are equal to each other. Wait.
5's blue, 3's
No,
red.
they did.
They add up to 180, right? So these are 180. So let's look at alternate interior. Okay, what are alternate interior angles?
Alternate interior,
5 and 4.
5 and 4? And 3 and 6. There we go. Alright, so these add up or are they equal? They're equal, right? They're the same colors. So these guys are equal. Okay. So, exterior angles. Two same side of the transversal, but exterior. What do you think? 2 and 8. And what's the other one? 1 and 7. All right, so those, do they add up to 180 or do they equal each other?
I'm sorry. 180.
180, right? If you look at it, they look like they should, right? 1 is bigger than 90, 7 is less than 90. Well, maybe I didn't draw it 100% right, but it's pretty good. So alternate into exterior. Okay, what are those?
2, 7, and 8, 1.
Yep, 1 and 8 and 2 and 7. Okay, so do these equal each other? Add up to 180.
They equal each other.
Yep. So those are the big
ones.
idea. Yeah, and that's how the labeling convention works. Now there's one type of angle that we haven't talked about yet. Okay? How about 4 and 8? Right? One of them's interior, one of them's exterior, but they're on the same side. We call those angles corresponding. Okay? Just like, okay, right, you guys might not think of the time this way, but I still do. The time is in a circle, okay? Right? Now, let's say this is another circle, and it's the circle that's on a map. Right? What goes with 3?
6.
And on a map.
Oh, 4.
Right. If this is north,
East.
yeah,
Oh,
right? So 3 corresponds to east, and that's the word we're using, correspond here. And it means to. Sometimes you hear the word respectively. Sometimes it's correspond. A lot of time we think about correspondence as communication between people, but it does just kind of mean that they're aligned somehow. If you take the communication aspect of it out, we would say 3 corresponds to east, and 12 corresponds to north. Right? They're just representing different things, but they're in the same place. So, right? 2 is in the same place as 6 is. They're just on a different intersection, right? So we say 2 and 6 correspond. Can anybody pick out another red pair that corresponds? 7 and 3. Okay, how about some blue pairs?
4 and 8.
4 and 8. And last one, 1 and 5. So those are our corresponding angles. And those are all of the different pairs that we will talk about. But I promise you, those words, same side interior, same side exterior, corresponding, alternate interior, alternate exterior, those are on the ACT. And they might not draw a picture. They'll just tell you that angle A and angle B are same side interior. Angle A is equal to 3x plus 4, and angle B is equal to 10x minus 30. And ask you to solve for x. And you will need to know from a mental picture that, okay, they're on the same side and they're interior. You might draw yourself a little picture and then be able to realize, okay, they add up to 180. Okay, so I think you can probably stop videoing.